Welcome class. So we are studying chapter number 7 of class 9 NCRT Science, chapter name motion. And in last class we learned about acceleration. And what is acceleration? It is rate change of velocity. Okay. And we begin by starting some questions. So in today's class, we will first continue the questions of acceleration. Then we will learn about the graphical representation of it. So let's study let's solve some questions related to acceleration. And question number first is, when will you say a body is in uniform acceleration and non-uniform acceleration? So in last class, I told you that acceleration is divided into two parts. One is uniform acceleration and other one is non-uniform acceleration. Okay, uniform acceleration is when velocity increases or decreases with same rate in equal interval of time, then that acceleration is said to be uniform acceleration. And when velocity increases or decreases unequally or in unequal amount in equal interval of time, then that acceleration is known as non-uniform acceleration. So we have to write those two definitions in these two questions. So let's see its detailed solution. A body is said to be in uniform acceleration if it travels in straight line. If we are constraining us in one direction and its velocity increases or decreases by equal amount in equal interval of time. Equal amount in equal interval of time, and that acceleration is known as uniform acceleration. And if a body is moving along a straight line and its velocity increases or decreases by an equal amount in equal interval of time, then that object or that body is said to be in non-uniform acceleration. Or if the rate change of velocity is not constant, v minus small u divided t is constant, then uniform acceleration. Not constant, non-uniform acceleration. This is other definition. Clear class? Okay. So question number 1 is clear. Question number 2, a bus decrease its speed from 80 km to 60 km in 5 seconds. Find the acceleration of the bus. So the bus initial acceleration was 680 km per hour, and the bus decreases its speed to 60 km per hour in 5 seconds. We have to calculate acceleration. So what is the initial velocity? Initial velocity according to this question is 80 km per hour, and final velocity is 60 km per hour. Time taken is 5 seconds. We have to calculate acceleration. What will be the formula used? formula used will be acceleration equals to v final minus initial divided by time, v minus u divided by t. Okay, so this is the value of acceleration. And we have talked about negative acceleration, which is known as retardation, and it mostly happens when you hit a brake. And if the speed of bus decreases, it means that the driver has hit the brake. So your final answer will have a negative sign on it. Clear, class? So all the quantities are given, and I have told you what will be the formula used. You just have to put all the value on the formula and calculate the acceleration. One more important thing is the time is in second, but this is in kilometer per hour. So you can either convert it in meter per second or convert time in hour. More convenient for us will be to convert these two quantities in meter per second. So first calculate speed in meter per second, and how we are going to do that. We know that 1 kilometer per hour is equals to 5 by 18 meter per second. So you can use this also. So initial speed was 80 kilometer per hour. We have converted 80 kilometer per hour into meter per second by multiplying by 5 by 18. The final answer is 22.22 meter per second. Similarly, final speed will become 16.66 meter per second. Time taken is 5 seconds. Then acceleration will be 16.66 minus 22.22 divided by 5. And final answer is negative 1.112 meter per second square. And you know why the negative sign comes here, because it's a retardation case. Retardation. Clear, class? So this question is also clear to us. Question number 3. Question number 3 is a train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. A train starting from a railway station. It is starting from a railway station. So its initial velocity is 0 because first the train was in rest, and moving with acceleration attains a speed of 40 km per hour in 10 minutes. We have to calculate the acceleration. So initial velocity is 0, final velocity is 40 km per hour, and it takes 10 minutes. So first of all, we have to convert this final velocity 40 km per hour in meter per second, and we have to calculate time in seconds. Initial velocity is 0 and we have to calculate acceleration. Formula used will be acceleration is equals to v minus u by t. So first convert velocity and time, velocity in meter per second and time in second, and then we will calculate the acceleration. Clear, class? Initial velocity is 0, final velocity is 40. We have converted kilometer per hour into meter per second, and it come out to be 11.11. Time taken, we converted minutes into second, and we know that 1 minute contains 60 seconds. So final answer is 600 seconds. Acceleration is 11.11 minus 0 divided by 600. So its acceleration is 0.0185 meter per second square. Is it clear, class? I hope this question is clear to you. Now let's move on to next topic. Here the acceleration part is completed. Now we will start a new topic, which is graphical representation of motion. So all of you have watched IPL matches, and in IPL matches sometimes they show this type of graph that, okay, at this over the team has uh, over versus score graph. Okay, in 10 over the team has made 60 runs. Okay, in 15 over, let's say team is playing well, 150 runs. Okay. So this type of score versus over graph we have seen in IPL matches. So this type of graph give us the overview that how a team is performing, how much score it is doing, in which one over. So this type of curved graph, or sometimes they show you the in form of bar graph. These graph contain the information that how well and how this match is going on. Similarly, in chapter motion, to understand speed, velocity, we will take a help of these type of graph. So we will study about the graphical representation of motion. Graphs provide a convenient method to present basic information about a variety of events. So graph provides a convenient method to present the basic information. For example, that IPL1 graph, which giving lot of information about how a team is doing, in which what a team is doing, in which over, how much, in which over, how much it scored. Is the slope is going upward? If the slope is going upward, it means team is doing very good. If slope is going downward, it means that it is making less runs. Okay, so graph give us lot of information about lot of events taking in one place. For example, in the telecast of one day cricket matches, vertical bar graphs are shown the run rate of the team in each over. Okay, over versus run rate score. Run rate bar graph is shown in one day matches. Over versus run rate, that in first over the run rate was 7, in second over the run rate decreases become 4, in third over run rate increases to 9, in fourth over let's suppose there was a wicket, okay, run rate become 2. So in the one ODI matches we mostly see this type of bar graph, run rate versus over graph, which give us the information how our team is doing. Okay, and it help us to understand the whole match. Similarly, in motion, as you have studied in mathematics, a straight line graph help in solving linear equation having two variables. Linear equation which has two variable, let's suppose x and y. Then straight line graphs can help us to solve these linear equation, and to describe the motion of the object we can use these line graphs. To describe the motion of an object we can take the help of these line graphs. In these cases, line graphs show dependency of one physical quantity such as distance or velocity on another quantity such as time. Let's suppose we are trying to make graph of time versus distance. Okay, 1 second, 2 seconds, 3 seconds. We know that In different interval, object can cover different distance. So for suppose at 1 second, the object has covered 2 meters. In second, the object has covered 5 meters. Similarly, in third second, in 4 second, let's suppose the object has come to rest. In 5 second, it has covered other more distance. In 6 second, it has covered more distance. And if we will join it, we will get a curve. And okay, it will help to understand in how much time, how much distance is getting covered by that object. And this line will help us to understand, predict velocity of any curve and velocity of any object. So we are actually making distance time graph, but it helps us to calculate the velocity or speed of any object. So you can understand that the graphical representation is very important thing. It will help us to understand motion more deeply, and it will help you to uh, decrease the effort, and it will make the calculation part easier. Now, so we will study first distance time graph. So in Cartesian graph, this is the x-axis, this is the y-axis. In distance time graph, in x-axis we generally take time, and on y-axis we take distance. The change in position of an object with time can be represented on the distance time graph adopting a convenient scale of choice. Scale means you want to take time in second, distance in meter, or distance in kilometer, time in hour, depends on you. Time is taken along x-axis. We take time along x-axis, distance along y-axis. Distance time graph can be employed under various conditions where object move with uniform speed, non-uniform speed, remains at rest, etc. So distance time graph help us to mainly understand and give us information about the speed, or object is in motion or is in rest. This is an example of a distance time graph, object moving with a uniform speed, and whenever any object move in a uniform speed, the slope or this line came to be straight line. If the object is in uniform motion, then the slope of the distance time graph is a straight line. Okay. We know that when an object travel equal distance in equal interval of time, then the object is moving in a uniform speed. So according to in this graph, we can clearly understand that distance is directly proportional to time here. Okay, and whenever you will remove this proportionality sign, a constant will come, and here that constant will be uniform speed. For uniform speed, the graph of distance traveled against time will be a straight line. So remember, whenever you will see the distance time graph, its slope will always give you information about speed or velocity. And if the graph is a straight line, it means it got uniform speed. Okay? So it has 2 points. Uh, one is this point is O, this point is A, this point is B, and their intersection is C. This time period is T1, this time period is T2, this distance is S1, and this distance is S2. The position OB of the graph show that the distance increase as the uniform rate A, B, O. So the portion OB of the graph show that the distance is increasing at uniform rate. At uniform rate means equal distance is getting covered at equal interval of time. Note that you can also use the term uniform velocity in place of uniform speed if you take the magnitude of displacement equal to distance traveled along the y-axis. So you can also use the term uniform velocity instead of uniform speed if the object does not changing its direction and you are considering the case of where distance is equal to displacement. We can use the distance time graph to determine speed of an object. We use distance time graph to determine speed. So distance time graph gives speed. Is it clear, class? We have to remember it. Distance time graph give us speed. To do so, consider the small part AB. Okay, so we have taken 2 points. One was A and B, and we are trying to understand the small part A and B. This is the graph, and we are considering a small section A and B here. Okay, and we are drawing a parallel line along the x-axis or the time axis, and we are drawing a perpendicular line along x-axis or parallel to y-axis, and the intersection point is called C. So we can clearly see that a triangle is forming. This point was T1, this point was T2, this point was S1, and this point was S2. So what will be the time interval of or the distance between A to C? Time interval between A to C will be T2 minus T1. So AC is denoted by the time interval which is T2 minus T1. And what will be the time interval corresponding to BC? It will be S2 minus S1. Okay. So we can see from the graph that the object moved from the point AB will cover S2 minus S1 distance in T2 minus T1 time. Okay, any object which is covering the distance AB, it means that this object has covered S2 minus S1 time distance with respect to T2 minus T1 time. And this is known as speed of the object. So from the graph, we can clearly understand what is the speed of the object. We can also plot distance time graph for the acceleration of the motion, but we are going to study this topic in the next class. In today's class, we have solved problems related to acceleration and we have started the topic graphical representation of the motion. And in graphical representation of the motion, we have indicated how you are going to indicate what will be the velocity according to the time intervals. So see you in the next class. Thank you so much.